Section 7.6, the natural logarithm. By the end of today's lesson, students are going to be able to evaluate and simplify using the natural logarithm. The natural logarithm is when you have a base of e. So we did this back in section 7.4. When I give you e, the inverse, changing it to log form, is where you would just write ln x because the e is invisible down here. It's assumed, okay? So it's still base exponent number, but you don't have to write it. It's invisible. First, we're going to look at how we simplify using our natural logarithm, and we're going to use the same properties that logs have, only when we go to change it to bin form, we have e as our base, okay? So, first make the 2 the exponent, and then since it's a plus sign, we're going to rewrite it as multiplication. And then 7 times 5 to the second power gives me the natural logarithm of 175. That's all we can do since there's no equal sign or an x. That's our final answer. Okay, let's try example 2. So this time I give you 3 times the natural log of x minus 2 times the natural log of 2x. Okay, again, make 3 the exponent, make 2 the exponent. So I have the natural logarithm of x to the third minus the natural logarithm of 2x to the second power. And then since it's minus, we would write it as division, so natural logarithm out in front, x to the third in the top, 2x to the second power in the bottom. Now we need to keep simplifying this, so we need to distribute our 2 to both of them. So that gives me the natural logarithm of x to the third divided by 4x to the second. Since there are x's on the top and the bottom, we need to combine them. So x to the third divided by x to the second. Remember, you subtract the exponents, so that simplifies to x on top, 4 on the bottom. Moving on to solving a natural logarithm. So first thing we want to do is make sure that it's condensed, and there's only one natural logarithm, which it is. Remember the base and invisible e. So I need to change this to bin form. So I'm going to write e to the second power equals x, and then you get to pick up your calculator and find out what that is. So e to the second power becomes 7.389 equals x. Example number 4, we have the natural logarithm of 3x plus 5 quantity squared equals 4. So there's 2 ways of doing it. You could just change it right now to exponential form, or you could bring the 2 down out in front and then divide by 2. It's up to you. So again, this is my base, so e to the 4th power equals 3x plus 5 squared. To get rid of to the second power, I am going to take the square root of both sides. The square root of e to the 4th is just going to be e to the second, and remember, every time you take the square root, it's plus or minus. Then, to get rid of the 5, I'm going to subtract it. So I have negative 5 plus or minus e to the second power equals 3x. And then to get rid of the 3, I divide both sides by 3. So my final answer is negative 5 plus or minus e to the second power divided by 3 equals x. Our 5th example causes us to use the properties of logarithms. So, since the natural log of 2x and the natural log of 3 are separated with a plus sign, we are going to multiply them together. So 2x times 3 gives me 6x. Now that it's condensed to one logarithm, change it to bin, so e to the second power equals 6x To get rid of the 6, we divide both sides by 6. So your answer is e to the second over 6 equals x. Now we're going to go the other way around and we're going to be solving exponential equations. So we have e to the x minus 2 power equals 12. So first thing you want to do is get the e all by itself. So this is my base, my exponent, my number. We change it to logarithmic form. So we use the natural logarithm because it has a base of e, and then we write our number equals x minus 2. Remember, you don't have to write the base of e because it's assumed it's there, it's invisible. All right, then to get rid of the minus 2 on the other side, you would just add 2. So your answer is the natural logarithm of 12 plus 2 equals x. You cannot combine the two of them because the natural logarithm of 12 is some crazy decimal, okay? And it's not the same thing as the natural logarithm of 14. Example 7, we have 2 times e to the negative x power equals 20. So first thing to do, get the e all by itself, so divide both sides by 2. E to the negative x power equals 10. Now change it to logarithmic form, so the natural logarithm of 10 equals negative x. To get rid of the negative sign out in front, you divide by negative 1, and it doesn't make it negative 10, it just makes it negative natural logarithm of 10. So you might want to add your parentheses as soon as you change it to log form, because you cannot ever change that number after you switch it to logarithmic form. E to the 3x plus 5 power, e to the 3x power plus 5 equals 15. So first thing, get the e by itself, so let's subtract the 5. So e to the 3x equals 10. Now change to a natural logarithmic form, so ln of 10 equals 3x. Remember, once you change it, can't touch it. Then to get rid of the 3, divide by 3, so your answer is the natural logarithmic of 10 divided by 3 equals x.